Hello friends, today I am going to explain about Java memory model. Java memory model is one of the important concept in the Java world. So where generally Java developers, they also should know about this Java memory model, the building blocks of Java memory model and how Java memory works internally, so that it will be useful not only for developing the programs. Generally Java developers, it is not their duty just to write the programs and execute the programs, but whenever we get memory issues, okay, and when we want to troubleshoot those issues, okay, so this Java memory model, understanding the Java memory model is one of the very important concept that every Java developer should know, and so that we can troubleshoot easily which part of the memory it has occurred and why the memory issue has occurred. So all this troubleshooting and root cause analysis can be done easily when we know the concept of this memory model. Now I will be explaining about starting what are the various building blocks of Java memory model, and then we will see how actually Java memory model will actually work. Okay, I'll just maximize this one. Okay, so these are the building blocks of Java memory model, and all the memory will be residing in the JVM. Okay, your Java virtual machine is the heart of your Java programming. So this JVM, if you see, it divides the memory, or we can say the memory is divided in the JVM in 4 blocks. Okay, generally in some books actually different scenarios will be given, like memory is divided into 2 parts, okay, or memory is divided into 3 blocks, okay, but for my understanding and so that I have made this as easy, so this JVM is actually, we can have 4 memory blocks in this. So one is stack memory, another one is heap memory, another one is non-heap memory, another one is cache memory. Okay, I'll be explaining what actually heap memory will do, what non-heap memory will store, what cache memory, what stack memory will do. But these are the 4 building blocks, fundamental building blocks of Java memory. Okay, Java memory model. Now we'll be seeing one by one. I'll just take now one by one and I will explain what in detail. Now let us first see heap memory. What heap memory will contain? Heap memory will store the objects. Heap memory will contain the objects. So your Java is an object oriented programming language. All the objects are stored in the heap memory. Okay, this heap memory is divided into 2 sections. One is young generation and another one is old generation. All the newly created objects are stored in the young generation, space, and once the objects have become old, that means once the objects are being survived from the garbage collection, so they are moved to old generation. What do you mean by survived by garbage collection? So garbage collection is another important JVM feature. I will be explaining in another video. So garbage collection is the we can say it is actually a process where the objects are removed from the JVM when those objects are of no longer use. Okay, so for example, if I create an object, and if that object is being pointed to a null, or if that object is not being referenced by any other object, or if that object is not referencing any other object, so then that object will be is eligible for garbage collection. So then it can be removed from the JVM. Now whatever the newly created objects are there, those will be stored in the young generation space, and if those objects are being survived from the garbage collection cycle, those are moved to the old generation. Okay, in the old generation they will, so those are all long lived objects, okay, which we call it as tenured space also. Now in young generation again it is divided into 3 spaces. One is Eden, one is S0 and another one is S1. What is S0 and S1 is, there are 2 survivor spaces. First survivor space, second survivor space. Now all the newly created objects are stored in Eden, and from there some older objects are moved to survivor object, first survivor object space. Next some more older objects are moved to second survivor object space, so that Eden will store only the newly created, fresh newly created objects, and S0, S1 will store somewhat bit older objects. Okay, now Now if the objects are still survived from the garbage collection, so then these objects will be moved to the old generation object, which are called long lived objects. Okay, now so these are all permanent objects which actually reside. And if you see here, in garbage collection there are two cycles that happen, two types of cycles we can say. One is minor GC and another is major GC. Minor GC will actually evict the objects that are present in Eden S0, S1. Evict means it will remove. Minor GC will remove the objects from Eden S0, S1. Now still if the objects are being survived, okay, so when actually garbage collection will decide to survive the object or not to survive the object, when the object is of no longer use in the application, then the object cannot survive. If the object still is being referenced by the other objects, okay, still the object can be survived, then garbage collection will not remove those objects. So those objects will be moved to long lived objects. So your minor GC will evict these the objects present in these three spaces, and your major GC will evict the objects that are present in long lived objects. Now once the objects are in long lived objects, now the objects are of no longer use, okay, then they will be removed in the major GC, okay, they will be removed. So this garbage collection is one of the important functionality in the JVM. What actually it will do is, it will what we can say, it will optimize the memory. It will optimize the memory thing, so that imagine that if GC would not have been there, how much your JVM will occupy the objects, how much space will your JVM will have to accommodate all the objects. So your GC is the cycle, or it is an algorithm that actually checks for the existence of the object, which objects are of active, which objects are of no use, no longer use. So your GC will decide to evict those objects, and your heap memory will act as a storage layer to store these young generation objects and your old generation objects. And also there is some reserved space in your heap memory. So what this reserved space is doing, it is a kind of a buffer. So if you want to actually have some more space in your young generation to accommodate more objects, you can use this reserved space. So similarly, if you want to have some more space in the old generation object to accommodate more objects, you can have reserved space. Okay, and if you see in your Java, when you run your Java program, typically whenever you want to increase your heap memory, you will be setting minus XMS, minus XMX. So what this minus XMS is, this is your initial heap memory. Minus XM, there is XMX will be your maximum heap memory. Your initial heap memory will be space required for Eden, space required for S0, space required for S1, space required for long lived objects. So this memory occupation from these four places is your initial heap memory, and your maximum heap memory will be adding your reserved spaces between both from young and old. So this will be your maximum heap memory setting. So this is how the heap memory works. And next we'll go to non-heap memory. In non-heap memory, this is another building block of Java memory model. In your non-heap memory, all the objects that are not stored in the heap memory will be stored here. Okay, so your non-heap memory is divided into two parts. One is your pure non-heap memory, another one is your cache memory. So what is your non-heap memory will store? It contains permanent generation space and your reserved space. So you might have come across some of the applications will throw an error like permgen space exceeded. So all the objects that are stored in the permgen will actually be stored in the actually whenever there is a memory full in permanent generation, you will get that error. What actually permanent generation space will contain? Okay, it will contain the runtime constant pool, field and method data, code for methods and constructor, intern strings. So all your string literals, for example, in your Java program you will be using string str is equal to double quotes ABC. Okay, string str equal to xyz. So those are all string objects, but those are all not created from heap memory. Those are all created from string literal which are present in the pool. That pool is present in your permanent generation space. Okay, those are not residing. Those are not residing in the heap memory. Okay, and also your method data, your constructor code, everything will be stored in your permanent generation. And what does cache contains then? Cache contains your JAT native compiled code. For example, in my same channel I have put a JAT compiler also. in one of the video. You can refer that, how JIT works. So for example, if you have a method that is being executed multiple times, okay, now you can use JIT. JVM will trigger JIT to optimize that. Generally, what is the function of JVM? JVM will interpret the code. It will read, it will take line by line code and execute it. Suppose if the same line is being executed in a loop, for loop 20 times, so interpretation will be slow. So what actually JVM will do is, JVM will trigger a just-in-time compiler. Just JIT will compile that code that is present in the loop, and it will execute only one time. Okay, so that you can see that JIT compiler, how it works in my earlier video. So that compiled code is stored in this cache, in this native code, so that it is for performance optimization. Okay, your compiled code will be faster when compared to the interpreted code. Okay, and so your cache will store all that JIT compiled native code. Okay, and you have actually, for example, when you say perm space, max perm size, so when you set JVM heap memory settings, so max perm size will be your permanent generation plus reserved. Okay, and if you give minus XX perm size, it will be only your permanent generation. Okay, and from Java 8, permanent generation is replaced by metaspace. Okay, and the another one is called stack memory. Your stack memory in Java is a multi-threaded world. So each thread will have its own stack memory. Okay, so what stack memory contains is, stack memory stores all your method execution data. So for example, if your method is having local variables, your method is having any other kind of, these local variables like int x equal to 2, int x equal to 3, and object references. So all this will be stored in the stack memory. For example, if you see in this thread stack, this thread is executing two methods. So method 1 is having int x equal to 2, int x equal to 3. So these are local primitive variables. So these will be stored in the stack memory. Method 2, in method 2 you have object data equal to new data. See, this small d data that is having data, small d, it is an object reference. And new data means this is a class, data is a class, you are creating a object of a class. That actual object will be stored in the heap memory, but the reference is stored in the stack memory. Similarly, this thread stack is executing one method. So where you have string a equal to abc. So this abc is a string literal. Okay, this literal is stored in the permgen. Okay, so like that. So this thread stack will contain your method execution data, and wherever the local variables are there, method local variables, those will be stored in the stack memory, and wherever your object references are there, those will be stored in the stack memory. But the actual objects, the object reference will be pointing to the actual object which is present in the heap memory. Okay, and if your method is having a for loop, which actually where JIT compiler can compile that into native code, so that native code is stored in the cache memory. So this is how your stack memory, heap memory, non-heap memory are interlinked with each other. Now we will see how a computer hardware is mapped to a JVM mapping. For example, I have this is my computer hardware and this is my JVM. In my computer hardware, I have actually RAM, CPU cache memory, CPU, and in my JVM, I have heap and thread stacks. Okay, for example, if you see, RAM main memory is your RAM is actually your main memory, and cache memory is a bit faster when compared to main memory, and your CPU is your core processing unit, central processing unit that process the instructions, and registers are small sized memories present in the CPU. Registers are very faster because CPU can easily fetch from the registers, so that the time taken for CPU to fetch the data from registers is very less when compared to cache memory, and the time taken for the CPU to fetch the data from cache memory is very less when compared to the main memory. So that's why cache memory is bit faster when compared to main memory. Registers are faster when compared to cache memory. Now, from the computer hardware perspective, there is no differentiation of stack memory data and heap memory data. So any data present in the heap memory or stack memory can be resided anywhere in this computer hardware. It can sit in main memory, it can sit in cache memory, or it can sit in registers. Okay, your heap memory data can be stored in registers. So there is no differentiation that heap memory will be stored in particular location in CPU in your computer hardware. So any of this JVM memory data can store in anywhere in this computer hardware. Now whatever I'm showing here is a single CPU architecture. So for example, even I can have multi CPU also. In multi CPU, what will happen? For example, in multi CPU, so this is my CPU, this is my CPU, okay, and this is my cache memory. For example, I'm taking a two core machine, and this is my main machine. So this is CPU, okay, this is CPU, okay, this is your cache memory, okay, this is your cache memory, okay, this is your cache memory, this is your main memory. Now one thread executing in first CPU will take the data from the main memory, okay, and stored in the cache memory. Now CPU, what it will do, it will say, for example, let us take a variable called counter, okay, in the program there is a variable called counter equal to 0. Now CPU will increment this counter by 1. So in your cache memory it will be, counter will be 1. Now this CPU will take the data from the main memory, okay, and in this cache memory now the same counter will be 0. Why it will be, counter will be 0? Because whatever the data that is obtained in updated in this cache memory is not updated to the main memory, okay. So your main memory will have the old data only, because this cache memory and this main memory is not synced. So thereby the other thread that is executing in this CPU will still read the value as counter equal to 0 from main memory. This CPU will increment this counter by 2. Now if you see, this CPU cache memory is having 1, this CPU cache memory is having 2. So these are not in sync actually, okay. So in order to have a synchronization, every time the data should be read from the main memory. That means whatever the data that is obtained from the cache memory, it should update in the main memory, and from main memory the other thread will pick it up, okay. So these are all synchronization issues. I'll be explaining again the synchronization, how we can deal with this kind of synchronization issues in another video, okay. So so this is what actually Java memory model will look like. I'll be just explaining just a very quick video on this what you say, string literal. When I say string literal and string object, see what will happen is, if you see, this is your string object created with new string operator. So this is your string literal, which is double quotes, which is enclosed with double quotes. This is actually present in the pointed to the permanent generation space, and this new string operator, this is created in the heap memory. Whatever created as an object will be created in the heap memory. This is string literal. Now when I say str double equals str1, what do we mean by double equals? So double equals means we are comparing the object identities. I am not using str dot equals of str1. If I use str dot equals of str1, then I have to compare the content that is present in the string. But I say str double equals str1. So that means I am comparing the identities of the object. So definitely this will be different, because the string literal is stored in the permanent generation and this is created in the heap memory. Both are two different locations in the memory, in the JVM memory. So definitely this will not be equal. Okay, if I see here, objects are not equal. Okay, if you see, objects are not equal because these two are different locations. Suppose if I use the same literal double equals ABC, well, now what it will do? Now both are pointing to the same string literal present in the permgen. So both are pointing to the same object. So that's why object identities are equal. Now sometimes what will happen is, I'll just say str dot intern. What do you mean by intern is, intern will check for the string literal in the pool present in the permanent generation space. So if that literal is not present there, it will create the object and store in the pool. Now that means intern also will point to the string literal pool, and ABC is also pointing to the same string literal pool. Now both our objects are equal. Okay, now if I run it, both objects are equal. Now sometimes what will happen is, I'll just say new string of ABC. New string of ABC. Now what will happen? This string will create a new object in the heap memory, and when I say str.intern, it will create string literal in the pool. It will see whether this ABC string literal is present in the pool. If not, it will create a new object. Okay, now I will just run it. Objects are not equal because this will create in a heap memory, this will point to the pool. So both object locations are not equal. Okay, this is how actually this I wanted to explain in the string demonstration video, string class when we see. But I thought actually because we are just dealing with the string literals stored in the permgen space and new string objects are created in the heap memory, I wanted to show how actually these objects are not equal and when these are equal. Okay, so I think you have understood the Java memory model. If any questions are there, you can post in the comment section. I will reply to your questions. Okay, thank you.